Hello everyone, welcome to ASR 9000 YouTube channel. My name is Thomas Wang. I'm the technical marketing engineer of ASR 9000. In today, we're going to talk about SPAN, also called Switch Port Analyzer. SPAN is a very efficient way to capture, mirroring, and also analyze the packet at the same time. However, SPAN requires a physical traffic generator or data analyzer to attach to the network device. In iOS release 7.1.2, there is a new feature called SPAN to File, which is a very flexible tool. It allows the customer can capture the data at anywhere, anytime. SPAN to File is a new feature has been created and gets supported on ASR 9000. It can be supported on all the generation of the line card as far as can load up the iOS release 7.1.2 and the after releases. In traditional SPAN, it allows the traffic from source port to be mirroring onto a dedicated capture port. But however, you have to connect a packet analyzer or traffic jam onto the network device. SPAN to File is a new tool. Rather than to mirroring to a physical port to attach to a packet analyzer, it allows the captured packets to be saved into a file, which that customer can be offload the file and do the analyze at a later time. The advantage of SPAN to File, it avoids a physical mirroring port and also a traffic generator or packet analyzer requirements. SPAN to File define a flexible way to capture the packet at anywhere, anytime. The SPAN to File can capture into the PCAP, PCAP format, and can be inspected for popular tools such as TCP dump or Wireshark. To define a monitor session that you can use the config monitor session name and specify either capture under the Ethernet or looking for IPv4 v6 capture. And you also need to specify the destination file about the size, buffer type can be linear or the circular way. And on the local interface, you can use the session monitor name to specify which of the monitor session profiles to be used. To start a packet collection that we can use monitor session with the session name, packet collection start. Then all the packet sending to the interface that you has been enabled the monitor session will be collected the data and saved into the file. Once you has been captured all the data, then you can use monitor session name, packet collection stop. If you're not satisfied with the capture packet, then you can discard the data. Or if you wanted to save the data, then you can stop, write the directory, provide the directory name so that you can save all the captured data into a file. You can check the captured data availability. For example, you define the save file under the hard disk, and you can dir to showing the PCAP capture files available on the hard disk. Then you can leverage on the TFTP or SCP to copy out the capture file into a server. And that where you can rely on any tools do the packet analyzer. In this session, we provide a SPAN to File demo steps. So we start from the monitor session creation and how to enable the monitor session under a typical physical port, and then we can check the monitor session status, and then start the monitor for the data collection. The monitor session can be stopped to write the file, the capture data. And once you has been saved the file, then you can SCP or TFTP the capture data files onto a server where you have the analyzer tools such as TCP dump or the whale shark to analyze the data. Okay, let's get started with a span to file capture demo. In this demo, I'm going to I have our IPv4 DHCP bits has been set up, and the traffic class will be populate to the SRv6. And since the transport is SRv6, I like to capture the packet along the data path to see how the IPv4 DHCP capture into the SRv6. Okay, here is my testbed. And as you see, I have ingress node, transit node, and egress node. And the traffic is actually sending from the CE side. That can be IP worth traffic and encapsulate on the ingress node, transport over the SRv6. And on the transit P router, that I like to capture the packets. The purpose I'm going to demo here is to capture the ingress data on the transit node to show the IPv4 packet DHCP bits has been populated into the SRv6 packet. Okay, let's get started. Okay, let's look into the ingress node. So as we mentioned on the ingress node, I have SRv6 transport to be enabled. And there is a traffic class propagate that will be copy up the IPv4 DHCP bits. And also, I have the ingress that I can show in here that the BGP prefix that I'm sending is actually carried out by the SRv6. On the transit node, the purpose is how we capture the ingress of these transit node, and later on, so that we can analyze the packet to see how the SRv6 DHCP and it being populated. And what we can do here is first we checking the monitor session, which has been already defined here. I have defined the monitor session 1 to capture the Ethernet with the destination file onto the line card. What we can do is to enable this monitor session onto the interface. I have this interface enabled, which is the 03011. That's the ingress. And here, as you see, I have the incoming IPv6 unique traffic has been like a keep transport into this port. And what are we going to do is the first of all, we can showing this monitor session status and make sure this is operational. And the second, what we can do is we can do the monitor session, start the packet collection. Monitor session packet collection start. What we can do is using the monitor session packet collection to stop, and in the meantime, writing the capture data into the file under the hard disk test directory. And the next step, I'm going to be copy out into a server, which I have the whale shark can do the capture. So you can use the TFTP, or here I just using the SCP to capture the files into my server. And with that, and I'm going to use the whale shark to showing how the data looks like. Okay, here is my capture, and I has been already copy out the capture files, and I load it into the whale shark. And this is one of the traffic stream, which is sending to the prefix 150.0.0.1. And as you see, inside they have the IPv4, and I have the DSCP CS5 has been, marking on the source of the traffic. And now I know this DSCP has been copied up to the SRv6 packet. And as you see here, I have these the DHCP bits, which is start with the 101. And this means that the IPv4 DHCP has been already populate the class bits into the SRv6. These span to file tools is very flexible, and you can define the monitor session, enable on any of the English port, and do the capture and copy out the capture files, and then you load up into the any of the packet analyzer. Here is the Whale-Shark, very popular, and then you can just do the analyze of all those packet or bits which you are interested. Okay, that's all the demo I have. Hopefully that you are interested and help you in the future. Thank you for watching.